Welcome to the DIY Honda Garage channel. The DTC P0135 indicates an air-fuel ratio sensor malfunction specifically related to the heater circuit of Sensor 1 in the Honda Accord 2023 and newer models. The air-fuel ratio AF sensor plays a critical role in monitoring the mixture of air and fuel entering the engine, helping the powertrain control module, PCM, regulate emissions and fuel efficiency. When the AF sensor detects that the signal to the PCM falls outside accepted parameters, the PCM registers this as a malfunction. It is essential for the AF sensor to heat up to function correctly, as a faulty heater circuit can cause inaccurate readings, leading to performance issues. This guide will troubleshoot the steps needed to diagnose and solve issues related to this DTC code effectively. DTC P0135 pertains to the air-fuel ratio sensor, designated as Sensor 1, which is responsible for monitoring the air-fuel mixture in the engine. It is located near the exhaust manifold, where it can accurately gauge the composition of exhaust gases. The A-fuel sensor transmits important data to the PCM, functioning to optimize fuel efficiency and minimize emissions. A malfunction in the heater circuit of the A-fuel sensor can lead to an incorrect signal being sent to the PCM, prompting the vehicle's engine control unit to disable certain functions as a precaution. The PCM depends on accurate data from the A-fuel sensor to conduct necessary adjustments in the air-fuel mix, ultimately impacting vehicle performance and emissions control. The primary culprits for DTC P0135 include a faulty air-fuel ratio sensor, an issue in the external circuit, or a malfunctioning powertrain control module, PCM. A faulty AF sensor can produce errant signals, leading to errors in air-fuel mixture adjustment. An external circuit issue may involve wiring or connections related to the sensor not functioning correctly, causing the PCM to perceive a fault. Lastly, if both the sensor and the external circuit are found functional, the PCM itself may be the source of the malfunction, affecting its ability to process sensor data. Accurate diagnosis is essential to determine the precise cause of the problem through effective repairs. Symptoms associated with DTC P0135 often include poor engine performance, increased emissions, and illumination of the check engine light on the dashboard. Drivers may notice sluggish acceleration, reduced fuel efficiency, or engine hesitation during operation, due to improper readings from the AF sensor caused by a heater circuit malfunction. The vehicle might fail to manage the air-fuel mixture properly, leading to higher emissions than usual. The check engine light serves as an alert to inform the driver that the vehicle's emission system requires attention. Ignoring these symptoms may ultimately result in more severe engine or emission system problems, making timely diagnosis and repair crucial. Begin the troubleshooting process by starting the engine and maintaining the engine speed at 3,000 RPM without any load, meaning the vehicle should be in either park or neutral. This step is crucial as it allows the engine to reach the operating conditions necessary for the radiator fan to activate. Monitoring the radiator fan is key, as it indicates that the engine is reaching the appropriate temperature and that the cooling system is operational. If the fan does not engage after a specified duration, this could suggest underlying issues with the sensor or other cooling components. Ensure to perform this step under safe conditions, allowing for a clear assessment before moving further into diagnostic procedures. Once the initial conditions are confirmed, the next troubleshooting step requires inspecting the AF sensor 1 directly. This includes disconnecting the sensor and using a multimeter to assess the internal circuit's resistance. Normal resistance for the sensor should be within 2.8 to 4.5 ohms at room temperature. If the resistance readings are outside this range, it indicates a malfunction within the AF sensor itself. In this case, the sensor will likely need replacement. It is essential to ensure that all readings are taken accurately and under stable conditions to avoid misdiagnosis before proceeding with further inspection. The next phase involves inspecting the IGPS LAF circuit, which supplies power to the AF sensor. Ensure the sensor connector is still disconnected and measure for proper voltage output. The circuit should demonstrate a battery voltage of approximately 12 volts when the ignition is on. If this voltage is absent, this could indicate an issue within the power supply circuit. It's also essential to check the integrity of the connections leading to the AF sensor, as loose or corroded connections can impede signal transmission. Proper operation of the IGPS circuit is a crucial factor in ensuring that the AF sensor functions effectively and accurately provides data to the PCM. Moving forward, the focus shifts to the inspection of the AF-HT-N circuit, which is essential for the heater function of the AF sensor. Begin by ensuring that both the AF sensor and the PCM connectors are disconnected before conducting the test. The objective is to check the circuit for open wires by measuring resistance levels. There should be less than 1 ohm of resistance, indicating a good connection. If resistance is higher than 1 ohm, it indicates potential breaks or defects in the wiring, which would affect the sensor's operation. Additionally, verify that the circuit is not shorted to ground, which could dramatically impact sensor performance and lead to erroneous data being sent to the PCM. The final troubleshooting step involves inspecting the powertrain control module, or PCM. If previous inspections of the AF sensor and both associated circuits returned normal condition readings, the PCM may be identified as the source of the problem. This step is critical because if all other components check out, yet the DTC persists, the PCM's ability to process sensor signals could be compromised. Ensure that the PCM has no fault codes unrelated to the AF sensor that could mislead diagnostics. As the brain of the vehicle's engine control system, a malfunctioning PCM can cause a range of issues, making it imperative to address any identified problems timely to restore proper functionality. Upon completing the necessary repairs related to DTC P0135, it's crucial to verify that all components are functioning correctly. This should begin with confirming that every replaced component, whether it be the A-factor sensor, wiring, or PCM, has been installed properly and operates within specifications. After repairs, use the diagnostic tool to clear the stored DTC from the PCM, ensuring that any history of errors is reset. Conduct a test drive to confirm that the malfunction did not return and monitor the vehicle's performance under various driving conditions. Observing the check engine light for reactivation is essential, as persistent issues require further investigation. In conclusion, effectively diagnosing and repairing DTC P0135 involves understanding the critical role of the AF sensor and its heater circuit in maintaining optimal engine performance. A structured approach to troubleshoot, including verifying the health of the sensor, inspecting related circuits, and ensuring the PCM functionality, is imperative. Engaging in careful inspections can identify external circuit issues and quickly isolate the root cause of the error. After completing repairs, monitoring the vehicle's performance will confirm that the issue has been resolved. Being proactive about issues concerning the AF sensor can enhance vehicle efficiency and reliability, preventing further complications. Please like and subscribe to the channel. See you next time.